Hello everyone, I'm Wang Zisheng. Here I'll present our project, Establishing Novel Object Recognition Task in half-fixed mice. Novel object recognition is a common method used to test recognition memory in rodent model. Lesion study combined with such behavioral tasks have revealed important brain regions involved in forming and maintaining the memory. Nevertheless, to study how neurons of this brain region achieve memory function requires measurements of their activities and connectivities in large-scale recording using in vivo two-photon imaging. However, such measurement depends upon animals' head to be fixed to harvest high-quality data. There is a need to develop behavioral tasks to test recognition memory in half-fixed animal. Here we suggest a solution to solve this problem. By transfer novel object recognition tasks into MHC system, an arena left by airflow, and allowed half-fixed animal to explore novel and familiar objects in such arena. Scientists explicit rodents' internal preference of novel objects over familiar ones to test whether subjects form proper recognition memory or not. We apply discrimination ratio to measure the preference of mice. Positive value means that mice prefer novel objects. The mobile home cage we applied are smaller than the enclosure used to perform novel object recognition. Thus, we first perform novel object recognition in an arena mimicking the size of a mobile home cage. To ensure that this behavioral paradigm could be repeated in a small enclosure, our resource suggests mice show the preference of novel object in small enclosure. After this, we implant metal strip on mice skull to restrict their head movement and training the mice to use a mobile home cage. By recording the position of two magnets under mobile home cage, we track the location, head direction, and speed of mice. Before novel object recognition task, mice would receive 4 days training, and the training outcome would be measured by moving index. The bottom panel shows that the moving index of mice do not improve across 4 days training. Further investigating shows the moving index significantly declined in the second hour of training. Thus, we shortened the training section to 1 hour to increase the animal number we could handle per day. Shortening the training section doesn't influence the activity of mice in the familiarization and test section. After 4 days training, there is one mouse cannot pass moving index criteria, which was called quiet mouse. We exclude this mouse from analyzing because the low activity of quiet mouse may lead an extreme value of discrimination ratio near 1 or -1. After this, we analyze the discrimination ratio of mice, which show no preference of novel object. Half-fixed mice spend most of time in resting, and due to this, we suspect the resting position mice choose may influence the discrimination ratio. To test our hypothesis, we calculate the discrimination ratio from the exposure time of moving period. The results suggest that mice show their preference to novel objects. Although the discrimination ratio in moving period shows their preference of novel object, but only one mice passed the explosion time criteria former article apply. To increase the explosion time of half-fixed mice, we modified few factors in our protocol. First, we lightening the mobile home cage to decrease the force mice encounter when they stop. Second, we added an airflow meter into mobile home cage system to ensure the air supply. Third, we changed the object pair to ensure the balance of mobile home cage. Fourth, we added a pair of training objects in training sections to habituate the mice to the existence of object. Fifth, we removed the habituation sections from protocol to shorten the experiment. Modified protocol significantly increased the exposure time and moving indexes of HEFIX mice in test session. Mice received modified protocols show no preference to novel objects, and this result may caused by their preference of certain object type or location. Further investigating animals' preference in familiar section exclude the second hypothesis. Mice show no preference to certain object location when objects existing in the arena were identical. This result suggests one object type is more attractive than the other. We modified the experimental protocol by shortening the training sections, reducing and balancing the weight of arena, adjustment of airflow, adding object in training section, and remove the habituation sections. This modification improved mice moving index and total exposure time. However, HEFIX mice still show no preference to novel object, but show the preference to one type of object. This preference can be eliminated by using pairs of objects that are equally interesting to animals.